Question 28. We don't normally like multiplying by decimals on a non-calculate paper. One method is to completely remove the decimals. So 3.67, I'm just going to write as 367. And then multiplied, 4.2, I'm just going to write as 42. Starting with a ones column, well, I know 2 times 7 gives us 14. So 4 down, carry the 1. I know that 2 times 6 is 12. Add the 1 I carried, give me 13. So 3 down, carry 1. And I know 2 times 3 gives us 6. Add the 1 I carried, gives me 7. Now multiplying by our tens column. As we're multiplying by our tens column, we start with a placeholder, i.e. 0. Now 4 times 7 gives us 28. So 8 down, carry the 2. I know that 4 times 6 gives us 24. And 24 add the 2 I carried gives us 26. So 6 down, carry the 2. I know that 4 times 3 gives us 12. Add the 2 I carried gives us 14. Adding up my two rows, starting on the right, I know 4 and 0 gives us 4. 3 add 8 gives us 11. So 1 down, carry the 1. 7 add 6 gives us 13. Add the 1 I carried gives us 14. So 4 down, carry the 1. 4 add the 1 I carried gives us 5. And here I've just got 1. I've worked out that 367 times 42 is 15,414. Whereas I wanted 3.67 times 4.2. Well, look at decimal point. For the first number, the decimal point has moved in 2 places to the left. Look at my second number. My decimal place has moved in 1 place to the left. Well, 2 places add 1 place is 3 places. Hence, I'm going to move the decimal point in 3 places. So 1, 2, 3. So therefore, my final answer is 15.414. Part B, work out 59.84 divided by 1.6. Well, I'm going to start by writing that as a fraction. So 59.84 is on the top, divided by 1.6. We never like dividing by decimal. I can do anything to a fraction as long as I multiply the top and the bottom by the same number. As it's 1 place in on the bottom, therefore I'm just simply going to times the top and the bottom by 10. 59.84 multiplied by 10 will give us 598.4. And on the bottom, 1.6 times 10 will give us 16. When dividing by 16, I could use short or long division. Alternatively, on a non-calculator paper, 16 is not the nicest number. I can use the double-decker method. Well, dividing by 16 is the same as dividing by 8 and then dividing by 2, because 8 times 2 is 16. Dividing by 8, the number you're dividing by always goes outside the bus stop. How many times does 8 go into 5? Well, it doesn't, so I carry the 5. How many times does 8 divide into 59? Well, it goes in 7 whole times, as 8 times 7 is 56. And as I had 59, the remainder is 3, so I carry the 3. How many times does 8 go into 38? Well, it goes in 4 whole times, as 4 times 8 is 32. As I had 38, the remainder is 6. Always keep the decimal point fixed. How many times does 8 divide into 64? Well, it goes in 8 whole times, as 8 times 8 is 64. Now dividing by the 2, I know that 2 divided into 7, 3 whole times, as 3 times 2 is 6. As I had 7, the remainder is 1. I know that 2 divided into 14, 7 whole times. Always keep the decimal point fixed. I know that 2 divided into 8, 4 times. Hence, 59.84 divided by 1.6 is 37.4. Question 21. That symbol that looks like a fancy E represents the universal set. That's the only numbers that can be written once in this Venn diagram. Here, the universal set is the even numbers less than 19. So I'm going to start by listing out the even numbers less than 19. In this case, they're going to be 2, 4, 6, 8, 10, 12, 14, 16, and 18, because they're the only even numbers less than 19. I'm told in set A, in the circle of A, we can only have numbers 6, 12, and 18. In set B, in the circle of B, we can only have numbers 2, 6, 14, and 18. When completing a Venn diagram, we always start in the overlapping region, as the left-hand circle represents set A, and here the right-hand circle represents set B. Therefore, the overlapping region is the numbers that are in set A and in B. In this case, are 6. Once you've used number, it's a good idea to cross it off the universal set. So 6, and also we've got the number 18 that appears in set A and in set B. And again, cross it off the universal set. Any numbers still remaining to set A, in this case 12, must be placed in the remaining part of set A. Once you've used it, again, cross it off. Likewise for set B, any remaining numbers, in this case 2 and 14, must be placed in the remaining part of set B. And again, cross them off from the universal set, so 2 and 14. Finally, any remaining numbers from the universal set, in this case 4, 8, 10, and 16 that have an array be included in the Venn diagram must be placed inside the rectangle, but not inside any of the sets, i.e. not inside any of the circles. So here I'm going to place 4, 8, 10, and 16. When subtracting mixed numbers, our first step is to convert any mixed number into a top-heavy improper fraction. To do this, we always keep the denominator the same, in this case 5. We always multiply to the side and always add number on the top. Here 5 times 4 is 20, and 20 add 1 gives us 21. Leaving the minus alone, once again converting any mixed number to a top-heavy improper fraction, leave the denominator the same, in this case 3. We always multiply to the side, and we always add number on the top. Well, 3 times 2 is 6, and 6 add 2 gives us 8. When subtracting fractions, we must have the same denominator. Here we've got 5, and here we've got 3. If we haven't got the same denominator, we want to find the first number that appears in the 5 and 3 times table, which in this case is 15. So I'm going to change each fraction to have a denominator over 15. What have I done to 5 to get to 15? Well, I've times it by 3. Whatever you do to the bottom, you do the same to the top to keep the fraction equivalent. In this case, 21 times 3 gives us 63. Look at my second fraction. I had 3, I've now got 15. What have I times 3 by to get to 15? I've times it by 5. Hence, I must do the same to the numerator, the top number, to keep it equivalent. In this case, 8 times 5 gives us 40. Now that I've got the same denominator, I can just keep the denominator the same, in this case 15, and just simply subtract the two numerators. Well, 63 take away 40 gives us 23. We want to give our answer as a mixed number. So how many times does 15 divide into 23? Well, 15 divided into 23, 1 whole times, as 15 times 1 gives you 15. And as we had 23, the remainder, therefore, will be 23, subtract 15, which gives us 8. So the remainder is 8, and it's always over the same denominator. In this case, our denominator is 15. Question 23. At the end of 2019, which house had a greater value? Well, looking at Tamara's house, at the end of 2017, Tamara's house was valued at 220,000. At the end of 2019, Tamara's house had decreased by 20%. When dealing with percentages, we know that 100% represents the original. In this case, 100% represents the value of Tamara's house at the end of 2017, which was 220,000. As we know at the end of 2019, Tamara's house had decreased by 20%. My first step is to work out 20% of its original. To calculate 20%, the quickest way to calculate 20% is to first of all calculate 10%. What have I divided 100 by to get down to 10? Well, I divide it by 10. Whatever you do to the left, you do the same to the right. So 220,000 divided by 10 will give us 22,000. What have I done to 10% to get to 20%? Well, I've times it by 2. Hence, do the same to the right to keep it equivalent. And 22,000 times 2 will give us 44,000. As we are told that Tamara's house had decreased by 20%, therefore we're going to subtract 20% from its original value. So originally, at the end of 2017, it was worth 220,000. It's decreased by 20%. We know 20% is this 44,000. So I'm going to now subtract the 44,000. I can't take 4 from 0, so I borrow from its neighbour. So 2 drops to 1, and I carry the 1. 10 take away 4 gives you 6. I can't take 4 from 1, so I borrow from its neighbour. So 2 drops to 1, carry the 1. So now I've got 11 take away 4, which gives me 7. And 1 take away 0 is simply 1. So the value of Tamara's house at the end of 2019 was 176,000. For Rahim, at the end of 2017, Rahim's house was worth 160,000. At the end of 2019, the value of Rahim's house had increased by 30%. So increase means it's gone up. So it's gone up, so we need to add on 30%. Again, when dealing with percentages, we know 100% represents the original. So 100% represents the price of Rahim's house at the end of 2017, which is 160,000. As we want to calculate 30%, my first step is to calculate 10%. If I done to 100 to get down to 10, well, I've divided it by 10. Hence, I must do the same to the right to keep it equivalent. Well, 160,000 divided by 10, that will give us 16,000. As that's 10%, and I want to get to 30%, what have I done to 10% to get to 30%? Well, I've times it by 3. Hence, I must do the same to the right to keep it equivalent. And 16,000 times by 3 will give us 48,000. As we know at the end of 2019, the value of Rahim's house had increased by 30%. So originally, at the end of 2017, it was worth 160,000. It's increased by 30%. So we're going to add on our 30%. We know 0 add 8 gives us 8. 6 add 4 is 10. So 0 down, carry the 1. 1 plus the 1 I carried gives us 2. So the value of Rahim's house at the end of 2019 was 208,000. Hence, Rahim's house had the greater value at the end of 2019, as 208,000 is greater than 176,000.